What if dark matter doesn't actually require any extensions to the standard model of particle physics, or even any new physics or new particles at all? Let me introduce you to MaCHOs. There's loads of evidence that dark matter must exist. So much so that I've already made 2 videos about that evidence. There just seems to be a huge amount of stuff in the universe that we just don't know much about. We know it must exist because of the effect we see it have on other matter like galaxies and galaxy clusters, but we don't know what most of it is. Many candidates for dark matter, like axions or WIMPs, require new particles to exist, and hence use new physics to explain the dark matter. The candidate we'll talk about here, though, seems to be able to explain dark matter without any new physics, and explains the evidence using only particles and objects that we already know about. This candidate is known by the broad term MaCHOs, Massive Compact Halo Objects. I know, we squeeze an acronym anywhere we can in astronomy. And it includes objects like tiny primordial black holes, neutron stars, and brown dwarfs. Basically, it's anything that's relatively massive but doesn't give off any light or radiation, so these things could be lurking about in galaxies, impacting the gravitational behavior of the galaxy, but not contributing to the light given off by that galaxy. In theory, it gives a very plausible explanation to much of the evidence for dark matter. These MaCHOs can speed up the orbits of stars in the outer regions of galaxies to explain flat galaxy rotation curves, and they can speed up the motions of galaxy clusters too. So let's take a look at the kind of objects that can be MaCHOs. As I said, they're usually defined as an astronomical body that emits little or no radiation, and they usually aren't associated to any planetary system, so they're freely wandering around in space. They're likely made of the usual, so-called baryonic matter that we're familiar with, but it's not completely ruled out that it could also be made of some other exotic matter that we haven't yet discovered. The types of objects that we typically think of as MaCHOs include neutron stars, which are dead stars that weren't quite massive enough to form black holes, white dwarfs, which are dead stars that weren't quite massive enough to form neutron stars, and even brown dwarfs, which are also known as failed stars completely. These brown dwarfs are objects a few times more massive than Jupiter, but they're still a little short of being massive enough to start nuclear fusion in their cores, which would make them a shining star. MaCHOs can also include much smaller things like rogue planets that aren't associated with a solar system, or even some asteroids as well. We also expect MaCHOs to include black holes, and more specifically, we often expect it to be primordial black holes, which are very small, sub-solar mass black holes that form in the very early universe, even before stars could have formed. We expect these black holes to be so small because the usual way we expect to observe a MaCHO is through something called gravitational lensing. And if the black holes that were making up MaCHOs were too big, then we'd see a lot more of them than we actually do. So they can only be these tiny ones, otherwise we'd have seen them by now. Gravitational lensing is when a heavy object gets in the way of a bright object on the sky, and it distorts the path of that light as it travels from a distant, bright object. This means that when we see the bright object, it can look warped or smeared on the sky, or we can even see multiple copies of the same object. Usually, the object doing this lensing is something huge like a galaxy, and the results can be impressive rings, crosses, or clear distortions. But for MaCHOs, we're actually looking for something much more subtle. In this case, it's called microlensing, because rather than having a whole galaxy to distort the light path, we only have one small object, be it a black hole, a neutron star, or a brown dwarf. This means that we don't see the usual, impressive, strong lensing that we might hope for, but rather microlensing just tends to very slightly brighten an object on the sky as the MaCHO passes in front of it. It does this only by a tiny amount, so we have to be staring at lots, i.e. millions, of bright background objects for a long time, of order years, in order to see this small effect. The hope is that there are enough MaCHOs to explain all of the mass that we think has to be contained in dark matter. And in that case, these events should be fairly common, even though they're so small. There are a few observatories actively looking for these microlensing events, including one that's simply called the MaCHO collaboration. However, the results haven't been too positive, and we simply haven't seen anywhere near enough of these microlensing events for MaCHOs to be the only thing that explains dark matter. They probably do exist, but they probably don't provide enough mass to explain all of the things like the flat galaxy rotation curves or the speed of galaxy clusters that we need dark matter to explain. As a dark matter candidate, MaCHOs are most appealing because they don't need any extension to the standard model of particle physics. This is just because they're made up of known constituents of the universe, or other collapsed particles in the case of primordial black holes. They're just in a form that's very difficult to detect. However, the fact that detection attempts through microlensing continuously come up short seems to suggest dark matter isn't made of MaCHOs. Or at least, MaCHOs don't make up all of dark matter. My opinion is that just like there's a huge zoo of standard model particles that we know about, there's probably an entire dark sector of things that contribute to the huge amount of dark matter in the universe. Maybe some MaCHOs, some WIMPs, maybe even some FIMPs, SIMPs and GIMPs, possibly even an axion and other more exotic particles. But what do you think? Do you think MaCHOs are some or all of dark matter? Let me know in the comments below, and please subscribe if you enjoyed the video. Until next time, stay safe team. I'll see you soon. Bye!